first thing to realize is there's a factor of 4 on both of the terms inside the square root. So that 4 can come out as a common factor as a 2, but then I've got a 2, a 2, and a 2 on the bottom. So this 4, this 4, this 2, and this 2 all mutually disappear together. Another thing that's interesting is to actually go through and finish out what's inside the square root. So inside the square root, what's left over is m1 squared over m2 squared times this v1 initial squared. That v1 initial squared is also, it's just like the 4. It can come out. So I'm going to do that. Am I going to do that? Yes. Yeah, sure. Why not? Let me do that. There's something kind of funny about taking it out, but I'm going to take it out. When I take it out, you know, when you take the square root of a square, the answer is a plus or minus, but I've already got a plus or minus. So yeah, I'm not going to worry about it too much. The square root, so v1 final equals, I've got m1 over m2 v1 initial plus or minus. Like I said, let me take v1 initial outside that square root, and what's left over inside the square root is m1 squared over m2 squared minus, and then this thing. It's 1 times m1 over m2 plus m1 over m2 times minus 1. Those are going to cancel. I'll have a minus 1, and then I'll have an m1 squared over m2 squared. So in the end, so this is kind of crazy, it's m1 over m2 minus m1 over m2 plus m1 squared over m2 squared, and then minus 1. All inside that parentheses, inside the square root. And then everything gets divided by 1 plus m1, over m2. So I'm still working, a little bit more to go. Inside here you can see with the pencil, I've got some things that readily cancel each other away. And I've got this minus sign. We'll change this minus sign to a plus, put this plus sign to a minus. So this equals m1 over m2 v1 initial plus or minus v1 initial times the square root of m1 squared over m2 squared minus, so plus a minus m1 squared over m2 squared. They cancel, right? And all that's left over is a 1. Isn't that cool? So all this crap turned into a 1. And then you divide by 1 plus m1 over m2. So what we get then equals m1 over m2 plus or minus a 1 divided by m1 over m2 strictly plus 1 on the bottom, multiplying v1 initial. So v1 final is this weird factor on v1 initial, so plus or minus. If you choose, let's see, what's the interesting one? Haha, what if I choose plus? What you get is v1 final equals v1 initial. This is what you'll get if the two objects miss each other. So this is the conservation of momentum and energy, or kinetic energy. it's the conservation rules for the elastic collision condition in case they just miss each other. Cool, right? What's the minus sign? So the minus sign is, instead it looks like V1 final equals, interestingly, yeah, I'm going to write down something and then I'll let you figure out how I could do it. But essentially I'm just going to multiply top and bottom by m2. So this will be m1, so I'm choosing the minus, so minus m2 over m1 plus m2 times v1 initial. So if they elastically collide, missing each other is considered elastic. Momentum is conserved. Also, the kinetic energy before and after the miss is the same. That's trivial. But this is if they actually do exchange momentum and kinetic energy, like this. Okay, so so I got a trick though. Remember, this was all based on a trick. So here's the trick. Before I do the trick, let me remind you that V2F, you get this. There's lots of ways to get this, but I just showed you what V1 final is, and you can go all the way back to our original interesting simple problem, and I just showed you how to get V1 final. We're supposedly given V1 initial. Can you see that you can solve for V2 final immediately? V2 final, it's actually right here. If I know V1 final, here's V2 final. So, but let me also remind you that what we just got so many things. We just got this, but I want to show you how to get this from this with a trick.